Welcome back to our grade 10 maths lessons. I am your teacher, Miss Awino. In our last lesson, we looked at algebra and how to solve equations. In today's lesson, we are going to look at the Cartesian plane. Okay? The Cartesian plane is made up of two number lines. Okay? So these two number lines are intersecting at right angles. How does that look? Okay? We have the vertical number line, all right, vertical number line, also known as the y-axis, okay? Then we have the horizontal axis or the horizontal number line, okay? That's the x-axis, okay? Now, when we use the Cartesian plane, we describe a point by using two algebraic terms. Okay, those algebraic terms are x and y. Okay, so a point is described by using x and y. X being the x coordinate of the point, okay, and y being the y coordinate of a point. Okay, now there is a rule for the order in which the points are given in terms of these two, x and y. Okay, x must always come before y. That is why this is referred to as an ordered pair. Okay, an ordered pair. Now, take for example the coordinates 2, 3 and the coordinates 3 and 2. They are not the same coordinates, or they don't describe the same point on a Cartesian plane. Why? Because in the first ordered pair, we find that the x coordinate is 2, and in the second ordered pair, we find the x coordinate is 3. If we were to plot this on the Cartesian plane, we will do that, but first we need to put in the numbers on the axis. Now, let's plot in the points 2, 3 and 3, 2. X coordinate 2 means you are moving 2 units to the right because it is positive, and you are moving 3 units upward, indicating that it is positive. Okay, so 2 units across, 3 units up. This is the coordinate 2, 3. Okay, now the coordinates 3, 2. This time we're moving 3 units to the right. So here, from your origin, we have 3 units to the right and 2 units up, which is here. All right, so 3, 2 are the coordinates that give the location of this point. Now, we move on from here. Because your x and y axes are intersecting at right angles, they form what are called quadrants. Okay, quadrants. Now, a quadrant is a quarter. Okay, and we identify the quadrants in an anti-clockwise direction. Okay, never with the counting numbers that we know. We usually use the Roman numerals. Okay, so this is quadrant number 1. Okay, and in an anti-clockwise direction, this is quadrant number 2. Then Coming down this way, this is quadrant number 3. And the last quadrant is this one. Okay? Now, let's say we have a group of or a set of coordinates. Let's see, the first point will be -4, 2. Remember, x before y. So -4 is here and -2 is here. Okay, so we plot that point first. -4, -2. Then we have -1 and -3. Okay, -1, -3. Sorry, it's right here. Okay. X is 0. That means it does not move away from the origin. Okay. So 0 is here and the y coordinate is -2. Then we have -1, +1, -1, which is here. Okay, we're plotting in our points. Now you can already see how your points are lying. It is showing us that it is in a fixed direction. Okay, the next point is 2, 0. Okay, x coordinate is 2, y coordinate is 0. Then we have 3, 1, which is located here. And the last coordinate is 4, 2. Now that's going to be just in here. Don't mind that. You can see it because we're using a different color. So, all right. Now look at the position of our points. It shows a straight line. Okay? So the linear relation is in fact a rule that we apply so that we can plot in our points. So if I draw a line to connect these points, you find that I have a straight line. Okay, a straight line. Now, important things about the straight line. If your straight line intersects or cuts across the x-axis, we call this an x-intercept. So I'm going to rule an arrow here. We call this x-intercept. Okay? If your line cuts across the y-axis, for example, this point here, we call this the y-intercept. Okay? Now, these are important points that you must know, important features that we are going to look at in more detail as we go through our lessons on linear equations and graphs. Okay? Now, y-intercept, x-intercept, the next thing we're going to look at is the gradient. Okay, now what is the gradient? Gradient is going to help us to find the equation of the line or the rule that these points follow to form that line. Okay, so the gradient is found, all right, gradient is found using two methods. We use the graph, okay, and we use 2 points on the line. Okay. Let's see the points, and we'll use this as an example. E.g. Before we do that, let me just list down the coordinates we are going to plot. Okay. So we have 2, 1, 4, 2, and we have 6, 3, and the next coordinate is 8, 4. All right, 8, 4. So we have 4 coordinates that we are going to plot right, so let's plot in these points. And then we'll find gradient. So 2, 1 is located right here. X before Y, remember that. Then we have 4, 2. To help us plot these points in, we can draw rectangle here to help us. So 4, 2. Then we have 6, 3. 6, 3. And the last coordinate is 8, 5. Now, we don't have the space, so we'll just leave that one out. Don't worry. 3 points is enough to draw our line. Okay, so we connect these. There we go. So we have a line. Now, what we are going to do to find the gradient using the graph, we need to form a triangle and then count the number of units we are going to use to find gradient. Okay, so I'm going to use the first point here and draw a line parallel to the x-axis. Okay, when I hit this point just below this point here, I will connect this and form my right angle triangle. Okay, now it might look like we are going to use Pythagoras, but we are not going to use Pythagoras. Okay, in gradient, we have a formula that we use when we are looking at graphs. Okay, so gradient, the gradient is equal to rise over run. Now, what is the gradient? The gradient is the measure of how steep the line is. Okay, it looks at how steep the line is. So we are trying to measure whether this line is very steep or it is less steep. Okay, so we use the formula rise over run, and we use the triangle that we have drawn on our graph. Okay, now the rise here would be the distance from here to here. So we are counting not the numbers here, but the number of units. So we have 1 unit here and another unit there. So our rise is 2. Okay, our run, counting the number of units, 1, 2, 3, 4 units. Okay, so 2 over 4. Simplify this, your answer is half, or you can give your answer as a decimal point, okay, or a decimal number. All right, so we have found the gradient using the graph. We use the formula rise over run. Okay, very simple. All you need to do is draw in a right angle triangle that you can use to identify the rise and the run. Now, the second method is to locate 2 points on the line that we are able to use. Okay, so what we are going to do, because I've given the coordinates already, we are going to use 1 point here, and we'll use this one as your second point. All right, so the formula given for using 2 points is, okay, gradient equal to y2 minus y1 over x2 minus x1. Now, where is y2 and where is y1? You might be asking. Go back to your coordinates here. This is coordinate number 1, and this one is point number 1 and point number 2. So we say that this is x1 and y1, and this second point will be x2 and y2. Once you've identified those points, you simply get them, substitute it into your equation. So from your coordinates, y2 is 2 and y1 is 1 over x2 is 4 and x1 is 2. All right, simplify this. 2 minus 1 is 1 over 4 minus 2 is 2. So we have used both methods and we found the gradient is the same. Okay, so half can also be given as 0.5. Okay, now we've looked at Cartesian plane, important features of the Cartesian plane. We've looked at the gradient and how to find the gradient. Now these are important points you need for the equation of the line or the linear relation. Okay, so this is the end of our lesson. In the next lesson, we're going to have a look at how to form the equation of the line from a graph. Okay, so I hope you have enjoyed this or understood a little bit more than you have. Okay, and I'll see you in our next lesson when we look at equations of lines. Thank you.